In number one, we're given a couple of different angle measurements, and what we're asked to find is the measure of angle JSM. Angle JSM is this angle right over here from J to S to M, but with a vertex of S, because that's the one in the middle. So that's the angle that we're finding. Number one, these two angles form a linear pair, which means that they are supplementary to each other. So if we do 180 minus 59, we get 121 degrees for angle JMS over here. We also have a quadrilateral down here, and you might know that a quadrilateral has angles that make 360 degrees. So if I do 59 plus 90 plus 48, and I subtract that sum from 360 degrees, I find that this angle over here is 163 degrees, angle MSA. And then I do need to recognize that these two angles are supplementary. So 180 minus 163 leaves us over with 17 degrees. And also, I want you guys to recognize that right off the bat, I could have eliminated these two angles because the angle that we're looking for is an acute angle, and these ones are obtuse. So just some multiple choice strategies there. We have a triangle, and the measurements are represented by 2x, 3x minus 15, and 7x plus 15. We know that if we take all three of those angles and we add them together, that will sum to 180 degrees because all angles of any triangle sum to 180 degrees. Combining like terms, we have 12x equals to 180 degrees. Dividing both sides by 12, x is equal to 15. Now I can take my x value and substitute in to find the angle measurements. We have 30 degrees. 30, 45 minus 15 is 30. And here we have 7 times 15 plus 15, that is 120. So we see here that this is an isosceles triangle. It has two equal angles, which tells us that it also has two equal sides. This one's a little bit tricky. Angle M and angle O are being bisected. So angle M is being split equally, and angle O is also being split equally. And we are also told that the measure of angle TMR is 28 degrees. So this angle over here, TMR, is 28 degrees. And we're looking for the measure of angle OTS. So we're looking for the measurement of OTS, this angle right over here. So since we know that we have angle bisectors, if this is 28, then its other half of that whole angle M has to be 28 as well. And that makes this whole angle M 56 degrees. If we take a look at the whole big triangle for a second, we now have two angles of this big red triangle. We have the 56-degree angle and we have the 40-degree angle. Remember, all three angles of any triangle add to 180 degrees. So if we do 56 plus 40 and we subtract that from 180, we get what the measurement of angle O should be. And the measurement of angle O should be 84 degrees. And that tells us that each half should be 42 degrees. Now, if we look at one of the smaller triangles, so I'm going to look at this triangle over here. Notice that once again, we have two angles of this triangle. We have the 28-degree angle here, and we have the 84-degree angle here. just like we said before, all three angles of any triangle make 180 degrees. So if I do 28 plus the 84-degree angle, and I subtract that sum from 180 degrees, then I find that this angle over here, the last angle of the green triangle, is 68 degrees. And that gives us enough information to find the angle that we're looking for, because now we have two angles of this small yellow triangle. We have the 42-degree angle, and we have the 68-degree angle that we just found. So if we do 42 plus 68, and we subtract from 180 degrees, we get 70, which is the angle that we are looking for. We are told that the obtuse angle that J Street forms with Brooks Road is 3 times the measure of the acute angle that J Street forms with Main Street. So we can represent this one as x because we don't know what the measurement is, and the obtuse angle as 3x. So the acute angle that J Street forms with Main Street is this angle right over here, and the obtuse angle that J Street forms with Brooks Road is this one right over here, J Street, Brooks Road. That's the acute. This one's the obtuse. So these two angles over here are both inside the lines, and they're on the same side of the transversal. So we call these same side interior angles. Same side interior angles are supplementary to each other. So when lines are parallel. And we do know these are parallel because they're streets, and streets in real life are parallel to each other. So we have x plus 3x equals 180. And if you thought for a second that they were congruent, just like ask yourself, do the angles look like they're congruent? This one's acute and this one's obtuse. There's no way they're going to be congruent. So we have 4x is equal to 180. So x equals to 45 degrees. And that's the one we were looking for. We were looking for the acute angle, which is represented as x. So that is 45 degrees. Which regular polygon will carry onto itself after a 135-degree rotation about its center? So this is rotation symmetry. And remember, we talked about how you could find rotation symmetry by taking a full rotation and dividing by the number of angles or sides that there are. So for the triangle in answer choice 1, a 120-degree rotation around the center would bring a regular triangle to itself. A 72-degree rotation would bring a regular pentagon to itself. A 60-degree rotation would bring a regular hexagon to itself. A 45-degree rotation would bring a regular octagon onto itself. None of these are 135 degrees. So now we're going to look for when it happens again, a multiple. Well, it's not going to be answer choice 1 because the next time after 120 degrees that it'll look like itself is another 120 degrees, which is 240 degrees, which is over 135. So it's not that one. The next 72, the next rotation of 72 would be another 72, which is 144. So that's out. We have 60, another 60 would be 120. Another 60 would be 180. 45, another 45 would be 90. Another 45 would be 135. So that's the one that we're looking for. And this one over here, first we have to figure out what translation's occurring. So if I just take this A and A prime, let's talk about what's happening here. So the x coordinate is increasing by 1, and the y coordinate is decreasing by 3. So our translation here is that we're going up by 1 on the x coordinates and we're going down by 3 on the y coordinates. So we just need to make sure that we continue that process. So next we have b and b prime, and this time we're given b prime. So we're going backwards. So instead of adding 1 to the x coordinate and subtracting 3 from the y coordinate, I'm going to do the reverse. I'm going to subtract 1 from the x coordinate. -5 minus 1 is -6. You can use a calculator for that. You're getting more negative. It's a bigger number when you get more positive, when you get closer to 0. And instead of subtracting 3 from the y coordinate, we're going to add 3. And let's double check if this works. So let's see if it satisfies the same translation as here. If I add 1, I do get -5. If I subtract 3, I do get 1. So -6,4 was the pre-image under this translation. Okay, now we have D and D prime. This one, they give us the pre-image, so we just have to apply the same transformation. So if I add 1 to the x coordinates, it becomes closer to 0, less negative, so that's -5. And if I subtract 3 from the y coordinate, that would give me -4. For this next one, we need to pick the answer choice that has the sequence of rigid motions that maps this triangle onto this triangle. So let's go through them. The first one says a reflection over the y-axis, followed by a reflection over the x-axis. And before I actually test it out, like exactly, I just want to see if the leathers are going to match. So if I flip this original triangle over the y-axis, and I'm a terrible artist. Once again, this is not exact, I didn't count. I just want to see the orientation. So when it flips over, that would be E prime, L prime, and T prime. And then if we flip it over the x-axis so that it's facing this way, L would go down here. It would be faced downwards. L would be down here, T would be here, and E would be here. So the leathers aren't in the right spots due to this transformation, and the triangles are not facing the ways that they're supposed to. So that one's out. Next one is a rotation of 180 degrees around the origin. So let's just see if in our minds if that would work before we actually try it. So if I rotate 90 degrees around the origin, let's say I'm just going this way because 180 degrees, the direction doesn't matter. So and just like before, I just want to see where the leathers are going to end up, the orientation. So it would go somewhere in this box 90 degrees and it would turn somewhere like that. And then 180 would move in this box and it would turn again. And as we can see here, the leathers wouldn't match up. The triangles would not be facing in the same direction. So just from visualizing that, oops, we can see that it does not take the triangle where it needs to go. The next one says a rotation of 90 degrees counterclockwise about the origin, followed by a reflection over the y-axis. For this next one, I'm going to see once again if it's reasonable. So 90 degrees counterclockwise rotation would be somewhere in this box, and it would be turned like this. And then if it was flipped over, L would match up with L prime, E would match up with E prime, and T would match up with T prime. So that sounds reasonable. That sounds like it could be. And then finally, the last one, so 3 might be it. And 4 is a reflection over the x-axis, followed by a rotation of 90 degrees clockwise. Oops, why does that keep happening? So if we're reflecting over the x-axis, it's the entire triangle is going to flip over. And then if we were to rotate this 90 degrees clockwise, oops, I reflected over the y-axis. Let's restart. We're reflecting over the x-axis, my bad. It's late when I'm recording this video. So we're going to reflect over the x-axis instead. So that's going to flip it down here. And then if we flip it over, T would match up with L. Not supposed to. L would match up somewhere here. As you can see, it would just be flipped over, but they'd be facing the wrong directions. So C is the only one that would work. So even though I suggest actually trying out the transformations, sometimes you don't have enough time to do that, like on a test. So you can see if the letters are going to match up, and that's a really great way as well of ensuring that you have the correct answer. So for the next one over here, we're looking for a line of symmetry, because if we're looking for which one is not a line of symmetry, because if it's a line of symmetry, it's going to carry it onto itself. So the line x equals 5 is 1, 2, 3, 4, 5. This line over here, vertical line, that is not a line of symmetry. In fact, if we reflect it over this line, it's going to go over here. It's not going to be in the same spot. It's going to be flipped over the line. Not a line of symmetry. So that is actually the correct answer. Let's go through the other ones. Y equals 2, 1, 2. That is a line of symmetry. If we reflect over that line, it will carry the figure onto itself. Y equals x. It is a line of symmetry. Y equals x is this line. It is a line of symmetry. It cuts it in half across the diagonal. And then finally, x plus y equals 4. I don't know what that looks like because it's not solved for y. So if I subtract x from both sides, and 4 and x, negative x don't actually combine, so I just left negative x here and I left positive 4 here. So remember, there's an invisible coefficient of negative 1. So the y-intercept is 4. So y-intercept is 4. And the slope of this line is negative 1. So that tells us that we're going to start at negative 4, at 4, and we're going to move down 1, right 1 to find more points. So let me get to my y-intercept. My y-intercept is 4. 1, 2, 3, 4. And now I'm going to go down 1, right 1, down 1, right 1. Keep going. Slope of negative 1. And we see that this is, in fact, also a line of symmetry. The line y equals negative x plus 4. Okay. Remember, guys, that after a rotation, congruent figures are produced. So the figures are exactly the same pre-image and image, including the side measurements and the angle measurements, because it's exactly the same shape. So the angles need to match up and the sides need to match up. They need to be the same as the ones that they were at the beginning before the rotation. So you can use the letters to see what matches up to what. A has to match up to R, B has to match up with S, C has to match up with T. So A matches up with R, that must be true. A matches up with R, not S, so that's not true. CB matches up with CS. Last two letters, not TR. CA matches up with TR, not TS, so not true. Okay. Over here, we're trying to figure out which value of x would make the lines parallel. So first, I'm going to fill in stuff I know. So I see a letter x, which tells me that we have congruent vertical angles. So I'm going to fill in the vertical angle with this 80 is 80. And I'm also going to fill in the vertical angle with this 30 is 30. And since all three of these angles here are supplementary, 80 plus 30 is 110. So we have 70 over here. And then by vertical angle relationships, this is 70 as well. I want to find the value of x that makes the lines parallel. And what I noticed actually is a letter Z. So I see that x is an alternate interior angle with the 70-degree angle that I found. If the alternate interior angles are congruent, that will prove that the lines are parallel. Remember, if lines are parallel, alternate interior angles are congruent. Conversely, it's also enough to say if I can find a pair of congruent alternate interior angles, that proves the lines are parallel. I'm going to write that here. If alternate interior angles are congruent, then lines are parallel. There's multiple ways to describe a sequence of transformation here. I'm going to do it just in one way. The only thing that you need to keep in mind is that you need to be as precise in your descriptions. If you're describing a translation, you have to say along what translation vector, along what line segment you're translating to be specific here because there is no grid. If you're describing a rotation, you do have to say around what center point, the direction, and by how much. And if you are describing a reflection, you have to say what line you're reflecting over. What I'm going to do is I'm going to first reflect triangle ABC over AC over its side. Once again, not drawn to scale. So when I flip it over, that's B and that's C. AC stays the same. Then what I'm going to do, and the reason I'm doing this is because now if I turn it, if I rotate it, A could match up with B, B could match up with B, and C could match up with C. So now I want to rotate, and I want to rotate around point A, and I'm going to rotate counterclockwise, and I want to rotate until AC and A prime, C prime are parallel. So let me show you what I mean by that. So I rotated counterclockwise, and I don't want to stop until these are parallel. AC and A prime, C prime are parallel. The reason I don't want to stop until they're parallel is so that afterwards, now they're positioned correctly the same way, then I can just slide this one down to make this one. And I can just slide down along A prime or along CC prime. That would work too. So I'm going to write this down over here. So number one, I'm going to reflect triangle ABC over side AC. Number two, I'm going to rotate around A counterclockwise until AC is parallel to A prime, C prime. That's an A. And then three, I'm going to translate along A prime. Here, there's multiple different ways that you can correctly describe a sequence of transformations. I'm going to talk about two pretty straightforward ways that you guys have. The first one I'm going to talk about is two reflections followed by a translation. So if I reflect this over the x-axis, let me move equal distances. 1, 2, 3, 4. 1, 1. 1, 2, 3. 1, 2, 3. So here's after a reflection over the x-axis. And then if I reflect over the y-axis, so 1, 1, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 1. Notice how after my double reflection over the x-axis, then over the y-axis, it's oriented correctly. R, O, C, and K is where they belong. It just now needs to be shifted up and over. So it needs to be shifted 1 unit up and 2 units to the left. So I'm going to write that down. I'm going to write here way number 1. Reflect over x-axis, then reflect over y-axis, then translate 1 up, 2 to the left. So that's way 1. Another way that you might have been thinking to do this is with a rotation. And I 100% recommend that when you are seeing what transformations work, that you try them out like I'm doing here on my grid. Because you might have just thought, for example, for the previous one, that 2 reflections would be enough. You might not have even seen that a translation was still going to be necessary. It's only by plotting it out and by actually seeing where the points are going to land and drawing it out that you can actually see if you're right. So now let's talk about way number 2. So way number 2 is that we can rotate by 180 degrees. You might have been thinking that as well. But then it's still going to need a translation. So that's what I mean by you should actually try it out to see that the points land where they're supposed to go. So I'll do this in parts. I'm going to rotate 90 degrees, and then I'll rotate another 90 degrees to make 180. I'll just go in this direction over here. It doesn't necessarily matter because if we rotate 180 degrees, we'll be going, it doesn't matter what direction you go in to get to 180. But once again, I'm just doing it in pieces. I'm just going to do 90 and then another 90. Okay, so that would be where point K falls. Where point C falls. Oh, and I might have forgot to mention, I'm rotating around the origin. Easier that way. Okay, so there we have after a 90-degree rotation. And now I'm going to rotate again to make 180 degrees. And I'm going to rotate again centered at the origin. It takes me a bit of time to rotate it. I'm doing it live here on camera. There we go. And that's after a 180-degree rotation. And now you can see that the points are oriented correctly. And what I was doing is I was counting boxes because it does have to be equally spaced from the center. So I was counting boxes to make sure my points were equally spaced so I could get like an exact rotation. And now I can see that I will still require a translation of 1 up and 2 to the left. So I'm going to write this down here. Wei Chu, rotate 180 degrees around the origin, and then translate 1 up, 2 left. And it's funny that it ended up being the same translation that we needed with the 2 reflections. So if rotations are giving you a lot of trouble with these kinds of questions, it's nice because a lot of the times a double reflection will get you to the same spot. So that's why I wanted to show it to you guys both ways. Okay, I'm going to just take a second and graph this quadrilateral. And the first thing that we need to do is reflect this quadrilateral over the line y equals 1. So the line y equals 1 is a horizontal line going through all of the y coordinates of 1. So here is 1. So this is the line that we're reflecting over, the line y equals 1. So let's do it. 1, 2, equally spacing all the points. 1, 2, 3, 4. 1, 2, 3, 4. So I'm just counting the spaces to the line and moving in equal distance. 1, 2, 1, 2 on the other side of the line. 1, 2, 3, 4. 1, 2, 3, 4. There we go. Okay. And now we need to rotate it 90 degrees clockwise, centered at the origin. So here's the origin. And I'm going to rotate this 90 degrees clockwise. One, two, three. 1, 2. 1, 2, 3. 1, 2. That is T. 1, 2, 3, 4, 5. 1. 1, 2, 3, 4, 5. 1. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. What was that one? H. And then finally M. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Did I not connect those points together correctly? There we go. I got confused with my handwriting. There we go. And it does say, does it say the coordinates? No, it doesn't. We should state our final coordinates. In fact, we should state our coordinates along the way just in case we don't get it correct. So that way we could get partial credit. So we should state our coordinates of after the reflection over the line. So that's 1, -2, -3, -4, -5, -6, 1, 2. A prime is -1, 1, 2, 3, 4, 5. T prime is -1, -2, 1, 2, 3. H prime is -1, -2, -3. Oh, oops. Tired. Let me try that again. 1, 2, 1, 2, 3. And 1, 2, 3, 4. 1, 2, 3. And then finally, for after we rotated the reflected trapezoid, the reflected quadrilateral, for M double prime, we have 1, 2, 3. I'm losing my mind here, guys. Negative. We went to the left. Negative. This is what happens when I'm doing this too late at night. I don't know which direction on the grid is negative and which one's positive anymore. There we go. Okay, so M double prime, we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. A double prime, 1, 2, 3, 4, 5, 1. T double prime, 1, 2, 3, 1, 2. And notice how the same numbers are involved. It should be like that. And H double prime is 1, 2, 3, 1, 2, 3, 4. There we go. Are the pre-image and image congruent? The pre-image and image are congruent because reflections and rotations are rigid transformations, which means that they keep the same side lengths and angle measures. And that is the last question on this oh no, that's not the last question on this review sheet. I thought it was. Let's move along then. Okay. So we're determining if AB is parallel to DC. We don't actually know if it is. So first, I'm going to use this triangle down here to solve for x, because I know that if I take all three angles of any triangle and I add them together, I get 180. Combining my like terms, subtracting 30 on both sides, now I can substitute in. 25 plus 19 is 44 degrees. 25 times 2 is 50, plus 6 is 56 degrees. 25 times 3 is 75, plus 5 degrees is 80. And over here we have a triangle as well. So all three angles of triangle ADB make 180. So 93 plus 43 is 136. 180 minus 136 gives us 44 over here. So what I'm seeing now in the letter Z, we have congruent alternate interior angles. And that proves to us that line AB is in fact parallel to DC. You can put that in your explanation. Let me actually write this better. Since angle ABD and angle CDB are congruent alternate interior angles, AB is parallel to DC. Last one, line AB and line CD intersect at E. If AEC is 5x minus 20 and BED is x plus 50, find in degrees the measurement of this angle CEB. So the two angles that were given are congruent vertical angles. Vertical angles are always congruent. And then after subtracting x from both sides and then adding 20 to both sides, the last thing I have to do is divide by 4, and I get 17.5. So let me plug in times 5 minus 20. Oops. So I got 67.5 degrees for the vertical angles. So these two are supplementary. So if I do 180 minus 67.5, I get 112.5 degrees for the measure of angle CEB, which is my final answer. So I want to make sure that I box it and make it clear that that's my final answer.